Where do the world's top data scientists and machine learning engineers think AI is really heading? How can you join them and break into your own data science, machine learning, or data analytics career? Those questions are what we're all about. My name's Jeremy, and welcome to the Mind the Machines podcast.
No matter what institution you're coming from, you can get access to the very latest research.
We also have to make sure that we're constantly revisiting our foundations and justifying why we're using the methods we are.
It's hard not to employ you. It doesn't matter what field you're in or what is it that you're good at. If you're good at something, if you like something with passion, there is someone who really needs you.
Christine Payne holds the distinction of definitely being the smartest person in the room right now. She studied physics at Princeton and went on to do neuroscience and medicine at Stanford. She then took a break from science for a while to work on her career as a musician, because of course she's a classically trained pianist to boot. And as if that wasn't enough, she's now with OpenAI, where she recently wrapped up a pretty incredible project that we're definitely going to be diving into today. So Christine, thanks so much for hopping on.
Oh, thank you for having me here. I'm excited to be here.
Very happy to have you. So maybe it's worth starting by setting the scene a little bit before we dive into your work at OpenAI, just because from your bio, I think there's quite a bit to unpack here. So how does a physicist turned neuroscientist turned classical pianist such as yourself actually end up doing this cutting edge machine learning research in the first place?
Oh, that's a good question. I think the connection between a lot of these fields is liking patterns. I sort of see it in music, the way the way you can find a structure in a piece, the way that you start out with a small scale thing, and as you get to know it better, you see the bigger picture. And I found that a lot in physics, where you sort of start out with little details, and then little by little you get this sense of a big picture. And it's also a lot of where I go is just I get curious about a problem, and I get excited, and I just try to learn as much as I can about that. And so that's led me through all these different fields. I'm super excited now, though, that I finally have a job where I get to connect all these different interests, because my whole life everyone's asking me, how are you going to connect math and physics and music? And I never had a good answer until now. So.
You're never going to use this stuff in the real world, they said.
Exactly.
Have you found that your ability to do pattern recognition in music helped you when you were, troubleshooting this the MuseNet model?
Yeah, absolutely. Actually, it was really fun. Like a week or so ago, I was trying to just add an extra thing where it was going to process the early part of a sample in parallel. And I managed to break something of it. And I actually could figure out what I had broken based on how the sample was going, because if the sample was really bad, I was okay, I've just it totally has no idea where it is. But then the sample was kind of okay. And it kind of made me think, oh, maybe it's an off by one kind of error. And then eventually I realized it was a mask that I hadn't set. But it really was hearing what was going on in the music pointed me to being able to fix what was going on. So that was really fun. It's also because I've just been listening to these samples for way too much. So I've gotten to know the model. I feel close to the model at this point.
It's such a great example of the importance of subject matter expertise when you're doing data science. It just hits you in the head when you're trying to debug stuff.
Yeah. No, actually, one thing I'm finding fascinating is that with the less powerful models, I could hear the music it would make sense very locally, but it would just fall into really easy patterns. If it got going on a scale, it would want to just continue on a scale, because that was a nice, safe thing to predict. And then as I'm dealing with these bigger models, it's able to know no human is just going to continue a scale indefinitely. Probably I should take a risk and move on to something else. So that's been really fun to hear in the music.
Did you choose to do this project, or how are projects allocated in OpenAI? Is it an individual thing?
This actually started, so last summer I did the Scholars program at OpenAI, which is a program that's specifically aimed at underrepresented groups in AI, and it's a 3-month program. And at that point, I was just trying to, learn everything about AI, and I was, learning about language models, and I figured, a good way, rather than just kind of click through somebody else's code, I should just try to build this myself, try to just attack a new subject and learn from that, and I picked doing it through music. So at that point, I just had a couple of weeks to do the final Scholars Program project, and did a little mini version of the music model. And then I ended up continuing on here as a fellow. And at that point, I was going to go on to a different project, but then I realized, like, you know what, it was really cool. And I only kind of scratched the surface of the project. And so I decided to dig into it more. So I think projects here, it's, you know, if you have a good idea for a project and you can convince a couple other people that it's something you can spend your time on, then there's a lot of flexibility.
There's a limited number of people who could do this sort of project, I feel like, because while it's possible for almost anyone who knows a language to be able to troubleshoot a language model reasonably well, like you're talking about timescales, like you see like these smaller language models, you see they make sense on like little mini timescales, but only a large model can make sense on the timescale of, like, you know, a paragraph or something like that. It's something like that in music, where I don't know if I would be able to like hear the problem with a locally sensical model.
Yeah, for sure. I think it helped a lot that I had both the expertise in music, but then also that, like, I love it enough that I was just wanted to work on it all the time. Like, even when I wasn't working, I was thinking about it or trying to figure out what was going on. So it helped to be obsessed with it.
Well, one of the really interesting things that Russell mentioned, actually, while we were talking about this before the call, was you saying from your blog, you're actually self-taught on at least the basics of machine learning data science,
yes.
which is incredible. I mean, obviously, it's almost the norm nowadays. But can you speak to that a little bit? Like, what was your journey like of self-teaching?
Sure. It actually started because I'm a pianist. And it's always bugged me that I have to turn my own piano pages. And so I was like, I should just make an app that turns piano pages for me. And I kind of got this going, but with an eye tracker, like an external eye tracker. And then I was like, oh, but it would be much better if I could just have a camera doing it. And I happened to be visiting Google I/O at that point. And they were like, there's this thing called TensorFlow. You should learn what it is. And you should. And so that was my start. That was nearly 2 years ago now. And so from that, I just started like slowly exploring, and I found Andrew Ng's courses online and kind of binge watched those, and then did the Fast AI sequence as well, which I love, and really dove in at that point. So yeah, it was. I do tend to be. I don't know, if there's a project that I want to figure out how to do, I just try to dive in and figure out how to make it work.
Nice. I think that's the best way to learn, if there's something you're super passionate about to drive you. Did you ever end up finishing that auto page turner, or did you get distracted by TensorFlow?
I totally got distracted. I keep thinking I should go back to it, because the eye tracker version is it works super well, but it's also super clunky because you have to bring your whole like laptop and your eye tracker and everything to the concert, and nobody wants to do that. So
as somebody inevitably asks you, like, oh, what's the equipment for? And then you have a 45-minute explanation ahead of you and your entire night's gone.
So for everyone in internet land, that is an open project: piano page turning eye tracker.
I know a lot of musicians who will want it, so it'll be very popular.
Maybe a startup request. Maybe a startup request. Is it? I'm curious now. Is it like it turns your pages? It's like, oh, you have your screen. It like digitally turns pages. In my head, I'm picturing a robot arm like turning the pages.
That sounds awesome too. But yeah, a lot of pianists work with an iPad or these foot pedals you can use, where you like hit the foot pedal and it kind of has a Bluetooth connection and turns the page. But I always find that the pedals start sliding away from me in the concert, and it gets really scary. And so that's why I was like, it would be much nicer with some sort of eye tracker, or you could just nod and have the thing motion detect. It should be totally doable. I just need to take the moment to actually do it. But someone out there should do it for me.
So what was the moment where you decided to transition then from this, I guess, page turning project to the MuseNet paper?
Yeah. So I think the more I dove into learning about deep learning, the more I just like loved the possibilities of it, and just really, really got into it. It's partly that, I actually always loved linear algebra in college and never had any excuse to use it after that. And like finally I'm like, yes, I can use this stuff. And like, it's all those intuitions are actually helpful. So it was probably just, when you kind of find a subject that clicks, this was that for me.
And one thing I noticed as well on the OpenAI website is you guys actually have the what you call the MuseNet co-composer now available for feedback. So do you mind kind of explaining, like, what does the co-composer do and what kind of feedback are you guys looking for?
Well, so the co-composer is basically an interface to the MuseNet model itself. So you're able to pick, you can choose your own way to start the piece, and then you can choose a composer or a band that you want to imitate, and then you click go, and that sends a request to MuseNet in the back, which generates a couple different completions or what it thinks of as possible completions, and it proposes those to you. You get to pick your favorite. You send it back to the model, it'll generate more, and you can kind of so that's why I think of it as like co-composing a piece with AI. And I kind of love the idea that at this point, someone who just likes music but doesn't actually know how to write out music or how to create it themselves can really have this experience of composing a piece that way.
I've actually used the first half of that feedback loop in the co-composer. I think there's one that's like, you can do a video game style. I think I did a video game style in Lady Gaga's Poker Face, and it had this really good. No, seriously. I mean, actually, let me see. I have it in my open tab here. If you guys want to listen, I actually like this. I like this quite a bit. One second.
Let's go for it.
That's Lady Gaga in the style of a video game. But you can, like, especially that last little bit, it's got such a video game feel to it. Like, it's almost like Super Mario Brothers in an alternate universe.
Yeah, oftentimes the generations take like a little bit to get going, and then once they do, I find them really fun. Like especially as a musician, to sort of realize the complexity of the music that it's capturing, I think is really cool.
It's almost like a kind of neural style transfer, but for music at that point.
Yeah, I'd love to. I think I'll push further on trying to get these style transfers in the future, but like I'm super excited that it's working at all now.
I'm curious, like, so I understand that you provide a few tokens or notes to get the thing started, and then it predicts what the most likely next note is. But yeah. I'm still a little lost on how exactly the style is encoded. Is it just like a subset of the tokens?
Yeah, literally right now I have a bunch of what I refer to as composer tokens. And so for each piece, I was always telling the model, like the very first token would always be, this piece is by Chopin, or it's by Lady Gaga, or whoever it is. And then the next one would always be, and these are the instruments in the piece. And then from there on would be the piece itself. And so then for these sort of style transfer things, all I'm doing is giving it the wrong like first composer. So then I'm sort of saying like, actually, even though it seems like the rest of the piece is Chopin, but pretend you're actually starting and you're the composer, somebody totally different.
So to you, who's feeding the inputs into the model, those first two things, which are which composer and which style, which instrument, which composer, those are two like data inputs that are the same as any of the other like first set of notes in the piece.
Yeah, I literally have there's a vocab of around 4,000, which is all the different piano notes, and I allow different volumes on the piano notes, and then all the different instruments, so like trumpet, violin, clarinet, everything like that. There are a bunch of wait tokens, which tell it like how long to wait before the next note. And then they're just like a slew of composers and bands and that sort of thing. So it literally just is a token that says.
So it's similar to a language model. Like it's actually, you've made a bunch of tokens that are all, wow, that's crazy.
Yeah, it's very parallel. And one of the things I like and how I first got into it was that things you learn about transformer architecture as you're doing music could help you out with language. Like they're the same kind of things of maybe you want to be able to direct the topic that the language model is going to talk about or something. You're
mentioning transformer architecture. That's like you've obviously gone to, well, I mean, almost by definition, the cutting edge of the field. I guess one question I have too, when I look at the transition that you made, what was the hardest thing for you getting into this space? Because when you go from physics to machine learning, there's so much stuff, any kind of STEM background to machine learning. What was it for you that was really like the biggest obstacle to overcome and break through?
I feel like the biggest thing that's happened to me is like over time, the number of things that I see in the code that I'm like a little afraid that I don't quite know how to do yet is decreasing. And I'm getting more confident that, whatever, it's just code. I can figure it out. There's, and things like that I've noticed gradually over time. And I'm also aware that there's that certain expertise that you only get when you've been in a field for years. And I know I'm like I'm kind of in awe, especially people around here at OpenAI who have that kind of like they've been living and breathing this forever feeling. But I think realizing also that because it is such a new field, there, you know, even the person who's like super smart at one thing probably doesn't know like a slightly different architecture or a slightly different approach or something. Like everybody has things that they wish they knew at this point, but haven't had time to read the paper or something. So just kind of feeling like it's okay to ask really stupid questions and that sort of thing.
Actually, this reminds me of, Russell published a blog post. Russell, could you kind of go into your thoughts there on the top-down versus bottom-up learning styles? Because I feel like this is just so relevant here.
I saw that. I love that. Go ahead.
Oh, thanks. Oh, well, yeah, just coming from a physics background, I think we're all used to like learning first the fundamentals and then sort of building on top of that to get a better understanding. Whereas I found learning machine learning, it was really helpful to just switch to a top down, you know, get something working first without fully understanding it, and then eventually like sort of diving in and getting the hang of it. I think that's especially why I loved, you mentioned Fast AI, had a very top down approach, right? The first lecture, you're doing state of the art image classification, and that feels really good. And it's super motivating to keep you going. So I think as soon as you have something you can like run and see the results, that helps a lot. And so you have to give up sort of that bias towards understanding how everything is working on the back end.
Yeah, that's fun. I was just sitting in on Jeremy's classes. He's doing the Fast AI version 2 right now, where they're kind of like breaking it apart and going down to the fundamentals. And I found that was like super helpful because that was like knocking out the last of my like, well, I don't totally know how this is happening. And then he invited Chris Latner in, and he was like, actually, you're still assuming a lot because you're assuming, you know, how this connects to the compiler and everything. And so then they took it yet another level deeper. So it's been cool to watch that. But yes, totally the top-down.
And that's great for as a way to learn because you're motivated before you get down to the ground level. I know you've because you're originally a physicist, obviously. Did you ever have during your transition from that bottom up to top down the feeling like, oh, I'm cheating somehow without knowing exactly how everything's working right from the, like, my professors will be so mad at me right now or something like that? I don't know. It's something I experienced.
Yeah, no, I think that's exactly it. And for me, it was sort of this like nervousness of like, it's because I'm too new in the field and I don't know this stuff and that kind of feeling. I think it's getting used to that and getting used to the fact that that's okay. And as you need to, you'll figure out those layers and that's just how you do it. And then it's better to dive in and break things and have that as a way to figure things out.
I think medically you can call it abstraction anxiety. The project obviously is like, it's incredible. It's very vivid. You have these amazing, there are these cool musical compositions that, I mean, I don't know much about music, but it strikes me when I listen to them that this is something new, fresh, and exciting. When you set out to do this project, were you thinking about like its possible impact on the future of music? Because it strikes me that this is like a whole other area to explore, where now you can have these fully automated compositions. In a way, I don't want to compare it directly to deep fakes, but there's sort of a parallel there too.
So I am mostly interested in how it'll sort of be human and AI cooperation. So I've just started working with a composer who's using MuseNet to, so like I've started training MuseNet on some of his pieces. So he'll be able to write prompts and then have it suggest things, and then he'll work that into his piece, and just that kind of feedback loop I'm finding really fun. And I'm really hoping it goes in that direction. I know it's putting whoever writes elevator music, I've probably put them out of a job, and I'm sorry.
I think all the elevator music that's going to be written has already been written. So
yeah, I hope it's true. Yeah.
Actually, one thing I'm like really curious and maybe excited about too is like I can imagine there's a category of people out there who are musically inclined, you know, have the ear, have whatever it takes, but just haven't mechanically gone and learned an instrument and learned. There's a lot of, you know, barriers to entry of just like, can you afford an oboe or like a physical trombone or a grand piano, which, you know, is incredibly expensive. And yet with this tool, I can actually go and say like, maybe I don't know music, but I know what I like. And so, and that's all I need. Like you just need a human filter to put your own heart and soul into the piece as you're filtering what the machine is composing. I don't know if you've talked to friends who are in that situation yet or anything like that.
I haven't specifically, although in a way, I think I'm in that category because I love music and I've played piano my whole life and I've always wished I were a composer or had that ability, and I just totally don't. And having been around MuseNet for the past month now is like making me feel like I can do composition, and especially part of it is like seeing it spit out so many bad compositions is making me feel more confident that like you don't have to always be good when you compose. You can also do like really awful things, and then every once in a while something great, and that's enough. But yeah, I do actually really love that idea that, you know, up until now, composing has always been, you have to choose this note and this rhythm. You have to do everything exactly at that level. And this allows you to move up one level and say, like, actually, I'm going to compose at the level of a couple seconds at a time, or really like how, like whatever scale you want to be doing.
This is like kind of generally the promise of these more sophisticated models in general. Is like it more and more it spares you from the cognitive load of diving down into the tiniest detail, the character level or whatever it is, and allows you to use your filters, which is still something that we have as human beings that are for the moment better than what we can build in terms of deep learning. Just allows us to filter for what we think is good.
And also just like our own, like what I think is good versus what you think is good. And we kind of get to put our unique stamp on it that way. Yeah.
You can make your own personalized compositions, like your own workout music of your own.
There's another kind of interesting layer to this too. And in a way, the fact that you use the GPT-2 model for this task, and it's been used before as a language model, and I'm sure there are a ton of other uses that it can be put to as well. But just the fact that you can use that same architecture for all these different tasks, it does imply, and I guess we live this as well in our own minds, when we say something like, this thing tastes like something else smells, or this piece of music reminds me of a work of art. There's a sense in which we are doing dimensionality reduction on the world into a level of abstraction where music exists on the same plane as visual stuff, which exists on the same plane as taste and all that stuff. I'm fascinated by the fact that this helps probe that. I mean, you're proving that there's some underlying symmetries that hold true for music that, you know, maybe allow us to have richer discussions about even the distinction between music and the spoken word.
Yeah, no, I think there's definitely a lot of exciting work in the future, maybe combining text and music, and as you're saying, since they can exist in these same domains this way, the same architectures.
Was there anything that surprised you about MuseNet's composition? I know when AlphaGo came to the scene, like a lot of Go players learned like new strategies based on the things that the AI decided to do. I'm curious if there's anything in the compositions that you were like, oh, that's interesting.
Actually, I think one of my favorites was, it's not exactly the same, but I had a model that had overfit a little bit to the training set. And so it was kind of doing Chopin pieces and it was staying pretty close to them. But it wasn't staying faithful note by note. So it was almost as if it had copied the piece like one layer up or something like that. So it basically like spit out a Chopin etude that I totally recognized, but none of the notes were the same notes. It was just like the same pattern in the left hand and the same runny pattern in the right hand. And to me, I was like, oh, this is so fascinating to be kind of hearing these pieces that I've known my whole life, but hearing them in brand new ways. So that I found really fun.
That's really interesting. You could almost like overfit it to your favorite artist to bias the model in a certain direction.
Yeah, I mean, that's actually what's kind of fun with this, with the neural net that's more towards art creation rather than a lot of the other ones where, you know, because normally overfitting is like, you're just absolutely not allowed to do that. Whereas for this, like, I don't know, maybe there's some ways that that's actually interesting. Like, obviously you don't want it to spit out a piece note for note in the training set because that's not helpful. But to have like variations on a theme kind of stuff is actually really pretty cool.
And do you think there's more that you can squeeze out of the model to go beyond what you've produced so far?
I hope so. I think we're at this point really interested to understand really both the capabilities and the limitations of these sort of models. For me, I keep sort of pushing on but can it do math? Like, I don't know if I haven't been convinced yet that transformer architecture can do like math really well and really reliably and this sort of thing. And for a little while with music, I had trouble getting it to create drum beats. And actually, you can probably hear that in the radio station, that sometimes the drum beats, sometimes they're good and then sometimes they lose the trail. And like one of my thoughts on that is like, well, it actually is having to calculate pretty precisely the amount of time that you have to wait before each next drum. And if it gets off a little bit, it's like having to add up all these past amounts of time that I had to wait. And that's like a fair amount of math that it's having to do. So things like that I find really interesting to see if like maybe the model will just get it with more training, or maybe there is actually some fundamental limit that we're bumping into, and we have to think of like the next addition to the model.
Well, this kind of lines up nicely with one of the topics we always like to explore in these chats, which is your thoughts on the future of AI. One of the big questions, obviously, is the dramatic question of the singularity and like when that's going to happen, all that stuff. And artificial general intelligence. So you've mentioned this incredible generalization ability of the GPT-2 model. We've NLP check, music check. Now you're asking, can it do math? Do you think it's plausible to argue that maybe we kind of have all the pieces we need, and we just need to put them together in the right way to actually produce a ridiculously powerful, independently intelligent AGI?
That's really tough. I do think that, the transformer model, like at the end of the day, it really depends on all the weights in all the parameters that you have inside the model. And I would certainly not claim that I've like gotten to the optimal set for that. I would certainly believe that if you could find your way to a much better setup, that would be a huge improvement. In terms of like whether this is enough for just like broad intelligence, I still think that humans have this ability to learn on a much smaller amount of data that we haven't captured yet. We're able to learn a lot about one topic and then realize that another topic is a little bit related, and we're able to like carry all that knowledge over. So I think there are things like that that I don't think we've figured out yet. I'm also a little bit concerned. I see like the way that we're training maybe one agent pitted against another agent, and they get better and better and better that way. And it's all this sort of competition approach. And I think we still have to figure out like, well, how are the agents going to learn some sense of morality out of this? How are they going to learn like, actually humans are useful and we should be taking care of them, even though like they didn't really help me in this competitive one against one situation that, trained the agents in the first place.
And do you think the problem there comes from the fact that it's one versus one? Just because humans evolved as tribes, and so it's a many-to-many interaction by default. And you could argue that that's the way that we learn to protect our genes and help our elderly grandparents and all that stuff. Do you think maybe that's a partial answer to this? Maybe it's not?
I think that's probably true. There's some, there might be some sense of like the agent needs to be rewarded not only for what happens to it, but also for, when it's what happens to its teammates or something like that. Some sort of sense of it's important to keep others and support others. And I definitely think that's, yes, the idea of having like multiple agents in a game is super important. And that might be how they learn to communicate with each other, or how they, learn some sense of morality or a tribe or anything like that. So yes, I think there's tons of work still to do in those areas.
They can't do math yet. So they can't do really complicated math yet.
We're not sure. We're still exploring. But yeah.
That's the incredible thing too, is that you can actually have a conversation about this thing that you've built from the ground up, and yet you're like, I don't know if it's actually able to do this. I don't know what I've built.
Yeah. We actually have a team here at OpenAI that focuses on trying to understand what's going on inside the neural nets and trying to see how these neural nets are making decisions, or just trying to understand what's going on. And so it was fun. As I was doing the music model, they were helping me to kind of visualize what was going on, or to make predictions. So as I would see each note, it would let me know these are the other options of the note that could have happened and how likely it thought those notes were. And so I could sort of see, is the model just like, it doesn't know, and here are like 20 different notes it could be, or is it pretty sure it has to be this one thing and a couple other good options, but not great. And so I think that sort of ability to visualize neural nets is extremely helpful.
That's really cool. It's like having a superpower, or like a diagnostic team for your...
That's exactly what I said. When they sort of introduced me to their work, I was like, I now have this superpower. It's not a black box anymore. Like I can actually start to figure out what's going on inside the neural net. I highly recommend it to anyone. It's worth taking the time to figure out how to do it.
Every engineer, every software engineer has this like debugger that they use. They have their favorite debugger. It would be great if like every deep learning engineer had their own like internal neural net debugger. Like what's going on at layer like 31?
And the people who work on the sort of neural network debugging aspect, did you say they were part of the ethics team?
Yeah, so we have a safety team here and a couple different subsets of the safety team. So there's a clarity team that's working specifically on this aspect of being able to see actually what's going on inside the neural nets.
So it's like you have the safety team, part of which is involved in the ethical question, part of it is like clarity, I guess all the different specialization, interpretability, all that stuff?
Yeah, because I think a big part of trusting that these neural nets might be safe in some way is understanding what might actually be going on inside of them. So.
That's a good point. You want to avoid a situation where a neural net is like, no, I love humans. They're the best. They're my favorite. But then inside, it's like, kill all humans or whatever, like the most horrible thing you can imagine is.
Are these conversations about ethics and morality and in terms of coding up these AIs, are those part of the like water cooler talk at OpenAI?
Yeah, they are all the time. Honestly, like we have this big lunchroom and we have these sort of wild conversations about this. Everyone's always trying to imagine like, how could this go well? How could it go badly? One of the things I love here is that all the teams are pretty intermixed. So I still feel like it's at the stage where I pretty much know most people here at the company. And so you do get to have these conversations where, and everyone's curious and they chose to be here at OpenAI because they care about this and about how AI will affect humanity, I guess, in the future. And so it is stuff that we end up talking about all the time.
I'm just curious, is the sentiment there like mostly optimistic about the future of AI, or is this sort of attitude like we need to like protect humanity from these potential dangers? Is it more of a pessimistic view?
Yeah. In one sense, it's like it depends who you talk to here, because there certainly are people on either side of that. I feel like overall it's probably a little bit more on the optimistic. It's like super important to be doing the safety research, but we're also like there's so many ways that this could be helpful. But I do think that you will find people here who are like, this is, yeah, I mean, I think we're all aware that we have a big responsibility because there obviously is this potential downside. And I think that's why we're all here, is to steer it as well as we can. And I do actually totally love that the safety team is just in the middle of all of us. And it's not like, oh, there's this team, some other site. And like, we know like, yeah, we're supposed to be thinking about safety, but it's, it's not really there, but it really is integrated.
And in terms of this bifurcation, basically, where you have some people who are like, oh, like the outcome's going to be, I think it's going to be great, AI positive and AI negative. What are some of the like main arguments you've heard for both sides, like for the AI positive and AI negative cases?
These are big questions. I mean, I think just in terms of the potential, I mean, you look at the medical applications or this ability to take out, all this busy work that we're doing and sort of let humans, think about the sort of more interesting side of projects, and just the sort of like unimaginable power of like what an actual AGI system could be. I think there's that tremendous possibility to do it really well and to have it sort of transform humanity in some new way. But I think everyone's really aware that, if you get to the point where you have software that's that powerful, we have to have confidence that we can align it with human values. And then there's this question of like, how do you even distill what human values are, and who gets to decide who those human values, like who gets to decide what those values should be. I think we're just aware that there are these really tough questions. And so, yes, I think the pessimism maybe just comes from, there are a lot of ways that you can imagine things going badly. But that doesn't mean that, there are ways that it could go in really fantastic ways.
Do you think that there are like well-defined sets of human values that you could pin down? I mean, this is something that like we've talked about a lot sort of in the background, but just this idea that you might argue that it's possible that there actually doesn't even exist a consistent, coherent loss function for every individual on the planet, or certainly for populations. Mm-hmm. And that you really can't come up with a set of moral laws, maybe even a loss function that captures all that dynamics. I don't know if that has implications for this, but if it does, have you given any thought to that possibility?
Yeah, no, it's something I think about, but I don't know that I have a good answer to. I mean, I was thinking about it even with respect to with GPT-2, in that, when we imagine like GPT-2 was basically learning from like the internet, right? So it's learning from the best of humanity and the worst of humanity. And somehow we're expecting this model to then be able to like only reflect our better parts and sort of, and we also like, I think ideally each of us would want it, like we each have a different idea of what a good, like, better part would be. Even like, you know, the way I would talk to a language model and like what I would find offensive is wildly different from what someone else might. And it's just this idea of trying to find some sort of like average what humans would want is just impossibly hard. And so I you know, it's interesting to think about how to tackle it, but I don't have a great solution.
One thing I read recently, I think from Stuart Russell, was you know, explicitly programming in uncertainty into the loss function. Because something humans do is like update our objective function based on new data. And so we're never really, I don't think anyone's really absolutely sure about their values. So putting an algorithm out there with a definite objective function might be the wrong approach.
Yeah, no, it's possible. And then, but there are certain absolutes that we would never want it, or like I assume that we would never want it to say, you know, kill a person, something like that. Like obviously that's something we want hard coded in, I think. But
yes,
you know,
there's
so many, like, I agree though, like, and it's super complicated to imagine like what, you know, where you want the absolute rules and then where you want this sort of flexible, like it would be nice for it to learn and adapt, and what our generation wants morality wise might be different from 2 generations from now.
Yeah, and I guess there's also the question of like whether that decision surface is really as well defined as it might seem. Like if you zoom in on the part where you say, okay, never kill anyone, it's like, okay, but under what, like, is that really true under every circumstance? Like,
yeah.
What about?
No, like honestly, sometimes I think about like, what would my ideal AGI be? And like, even when I just try to think of like, in the best case, what would it be? It's like, it's so hard. There's so many, so many fuzzy sort of cases like that. And so
that's the hardest part, is like, because the economy is moving anyway in the direction of making stuff that will eventually be able to do this on some timeline. As t goes to infinity, like, yeah, we're gonna have AGI, right? Like that's almost a foregone conclusion. But the thing that is not guaranteed, and the thing that is like very non-trivial, is like, what does good mean? Like, what does it mean to be good? Like, suppose you have God power over setting that loss function. Like, what do? I wouldn't know what to do. Like, I wouldn't have any idea what to do. And this is, you know, this isn't unique to OpenAI or anything like that. This is just a function of our civilization and where it's headed. Like, that's all it is.
Yeah. But this is also where, like, I hope that we continue to have more and more people interested in this and adding their voices to this, because I don't think it should be like our little group here making these sort of decisions. Like, this should be the world contributing to these decisions. So I hope
but the fact that you guys exist, I think, is really good, because it's great to have an organization that at least has a mandate to do this, and that is at least like to first order, isn't beholden to direct like money interests and any other interests that might move it one way or another. It's the best, like the best rough solution that we can put together as a civilization.
Yeah,
right,
that's why I'm here, so I agree with you, but yes.
And the attitude of OpenAI as well with respect to that GPT-2 paper, where, you know, the approach was very open and saying like, look, we're here for feedback. I mean, that was basically the gist of the key. We're withholding publication of the model more or less as a test, not because we believe that this specific model is itself dangerous, but because we want to test out what it would be like to adopt that kind of policy. Like, and to have that argument out in the open, I think is just absolutely necessary in this case, because society evolves by ensemble averaging. Like we by necessity need this kind of individual little decision tree stumps, and we need to be added together in a coherent way.
Yeah, no, it's interesting you say that. Actually, with this MuseNet release, it was just on Wednesday that Greg was like, and why don't you also throw together this like live concert and people can see like if the model goes well or if it goes badly. And I was like, that is terrifying. Like, what if it goes badly? It kind of is like what I like about OpenAI is that like they're like, just put it out there and like acknowledge that like the work you're doing isn't perfect, and there's going to be ways that it's good and ways that it's just like not there yet, and it's okay to just be open about that and not kind of like only show off the polished like this is how it's awesome side of things. So.
Which is also important as far as evaluating the model's performance is concerned too, I guess.
Absolutely, yeah.
Well, maybe the last quick question then to touch on the ethical side, because you did mention something about like with the morality of today versus the morality of tomorrow, and those might change too. Mm-hmm. So there's something like incredibly incredibly important about being able to account for that, and Russell alluded to that uncertainty, maybe that time dependence. Whatever loss function we figure out, the day OpenAI announces, hey, we have AGI now, I guess a human in the loop is going to be important somehow, some sort of way of having it track like the changes of moral flavor that come by society. Is that a strategy that you buy into? Is that a strategy that's sort of...
Yeah, I mean, one of the, actually under the safety team, one of the things they're working on is having debates between two different models, so that even if you get to the point where the models are, calculating things that are beyond human intelligence, they have to be able to kind of present their case. And then the idea is having two different models trying to poke holes in each other's arguments. That'll be understandable to humans, and then humans could help make decisions on where we want to go down a certain route. And so I mean, I think it's still a wide open problem, but how you get these models to align with human values and changing human values is super important.
I have a final question that's totally unrelated. So all four of us are physicists who in one way or another went into machine learning or AI. So
Yeah.
if you were giving advice to a physicist who wanted to go into AI, what would you tell them?
I mean, my big thing is just jump in, find a project that you think is cool, and try to figure out how to make it work, which is maybe like a physics way. Like, I feel like, you go into physics lab and it can be kind of scrappy and you're like, let me just duct tape this together, or whatever you have to do to make it work. And bringing that sort of mentality to it's kind of a fun field right now because there's just tons that aren't understood well. So there's a lot of room to just kind of tinker and try to make something that's a little bit better. So I think, dive in and have fun with it is my sense.
Dive in and have fun with it.
Not a bad way to go. Well, and a hell of a way to end an interview too. Thanks so much, Christine, for making the time. I know things are crazy busy. You guys are you've just released this incredible blog post, so I'm sure you're inundated.
Yeah. It's always great to do an interview on not much sleep, but thank you. It was great to be here. This is a lot of fun.
Well, for what it's worth, you were just as coherent as GPT-2, so that's...